Marcus.
Okay, so I'll have you shut the Chromebooks if you haven't already, because today's kind of hard to get sometimes. Okay, so we'll start off with this one. We have two different curves. Can anyone tell me what a curve is off the top of your head? Yeah, I saw someone do it. It's just not a straight line. So it could be like a U, it could be like a W, it's just not straight. So we're given two curves, the red function, the green or the blue function, and we're given 1 point of intersection. Just think for a second on how we could find the other ones. Does anyone have any ideas? What does a point of intersection mean? Where they cross. So what has to happen for the functions to cross? They have to be equal to each other. So, because they cross at -5, which was given, and then we didn't know these ones, but they have to be equal to each other to be a point of intersection. So we just set them equal to each other. When we set them equal to each other, what would we do after that? Yep, move them to one side. So we combine like terms. So we'd get x cubed. If we add x squared to both sides, 2x squared, add 5x, 23x, negative 23x squared, and then add 5 plus 60. And if we're given one solution, how do we find the others? Yeah, that's one, to get the y value. But how could we find like these ones? We were working on Monday. If we're given a 0, how do we find the other zeros?
Just plug in the next value.
Not quite. We'll use synthetic division. So we'll touch on that today too. So we'll kind of cover two different theorems today. The first theorem is if you have a polynomial of degree n, you're going to have n solutions. So like for a cubic, how many solutions would we have? 3. What about like a 6th degree? 6. That's all this first one is saying in a lot more words. Okay, but part 2 is saying if you have a plus bi as a 0, you're also going to have a minus bi as a 0. So if we looked at, like, let's say we had 5 plus or minus 6i, what's a minus bi in this? We'd have 5 minus 6i, and then we'd have the positive version with 5 plus 6i. So these ones with the i's, they'll always come in pairs. One with the positive, one with the negative. They use the buddy system. How do we feel on that? Because that's kind of tricky. Okay. So we'll cover the factor theorem where if we have a 0 of k, then x minus k is the factor. And then polynomial with degree n has exactly n zeros, including different multiplicities. And then the complex conjugate root theorem just says that the imaginary ones come in pairs. Okay, if we look at the one over there, how could we find the zeros? Well,
What if you isolate x?
yeah, we could isolate x.
He said factoring.
I mean, you could factor, it's difference of squares, but we'll end up in the same spot. So if I isolate x, what's my first step? So I get x squared is equal to 4. What do I do from there? If I square root both sides, what do I get? plus or minus 2. So what are my different zeros? -2 and +2. So how many times is -2 a 0? Just once. How many times is +2 a 0? Once. How many total numbers of zeros do we have? 2. And what's the degree of our polynomial? 2. What do you think the graph looks like? Is it going to open up or down? Let's start over there. If this is positive, it's going to open up. So if it opens up, where do you think it'll cross the x-axis? Yeah, +2 and -2. Okay. If we look at this one, what would we do? -4. So we get x squared is equal to -4. What's my next step? What do I get? (2i). So what are my zeros? Okay. What multiplicity does 2i have? 1. What about -2i? 1. What's the total number? What's my n? There we go. What about the graph? It's going to open up.
Imaginary axis.
Yeah. So if they're imaginary, does that cross the x-axis? No. So it's going to be hovering above it. Because the x-axis is down here. That's not going to touch it. How do we feel with that so far? Okay. So if we look at this one, it's just going to break down the complex conjugate root theorem. So if they always come in pairs, these ones will always be even. So if we have a 5th degree polynomial with 1 0, how many complex zeros do you think we have? We want them to add up to 5. 4. Because if we already have 1, we need 4 more to make up our 5. If we have 3 real zeros, how many complex? 2. What about 0 or 5 real zeros? Yep, 0. Because the different rows, you need to add up to the degree. So these ones are all even because they come in pairs. Okay, if we look at the top part, if 7 plus 5i is a 0 of the polynomial, so is what? Yep, 7 minus 5i. Okay, so the next one, a polynomial function of degree n with real coefficients has exactly n complex zeros. At most, n of them are real zeros.
I'm going to go true.
Why?
Wait,
You're right, but why?
Because if it's true, then there's like you can only have complex numbers, like real complex numbers, and so there can be no imaginary axis.
Okay, well, can we have, if it's n degree, can we have more than n roots? No.
You can't.
So at most, there's n.
But there can be less than two. I took a shot.
There can be less than n real zeros, but those would have to be made up by complex zeros.
Yeah.
Okay.
That is
Okay, if we're looking at this one, it's degree 4. So how many zeros are we going to have? 4. it says they could have -3, 1 plus I, 1 minus I, -3 plus 7I as its zeros. Is that true or false?
That's false.
Why is it false?
Because it's, yeah, because if you have, because you already have 4, because you can't have more than
Yep.
the n, the number of n, you
Yeah.
can't have more than that.
What about this? Does that have its buddy? Nope. So it's all by itself. That can't work. How do we feel about that? So-so? Okay. How would we find the zeros for this one?
First you gotta put it all on one side.
Get it back into standard form. So how would I do that?
Subtract 2.
So I get x squared minus 2x plus what?
Plus 1.
Equals 0. What do I do from there?
Very magic.
Do magic numbers work? Yeah, what would they be?
-1.
X minus 1, x minus 1 equals 0. How can I rewrite that? X minus 1 squared. Okay, so what's my 0? How many times is 1 a 0? Twice. So there's 1 0, but it happens twice. So what's my total number? And what's my n? Okay, what do you think the graph looks like for this one? It's not going to be a straight line. It's still going to be like a U.
Why is it multiplicity 2?
Because we have it twice.
Oh, okay. And then that makes the total 2
Yeah.
n equals 2 as well.
Yes. I don't know if you guys have covered this, but it bounces. That's what Oya says. So anytime it touches but doesn't fully cross it, it's going to have a multiplicity of 2. Yeah. Okay. So we're given 2 zeros and the degree of it. If n equals 3, then what's like the degree of the polynomial? 3, yeah. So we're given a 0 of 1 and 4i. What one's kind of implied there? -4i, yeah. Okay, so if I have the zeros, I need to find the factors to get the polynomial. Do you guys remember the factor theorem?
I don't even think I was
Okay, so if we look at 1, for example, that's saying we have x is equal to 1. We want it in the form x minus a number or x plus a number. So how would we get that for this? Yep, if we subtract 1, then we get x minus 1, and that is our factor from that 0. How do you feel about that so far? Okay, we'll work on it. But if we look at 4i, what would be the factor for 4i? X minus 4i. Then what about the red one? Yeah, it's going to take an extra step because it's x minus k is the theorem, but that is the same thing as x plus 4i. But you can skip to this step straight away. You don't have to do that one. So how can I get the polynomial from those factors? Distribute them. Would I want to distribute to this term?
No.
Why not?
Because imaginary numbers.
Yeah. So is there a way that I can kind of get rid of those?
Yeah.
How?
You can maybe divide by them.
I wouldn't divide. There's this little thing. It's like a minus bi times a plus bi is equal to a squared plus b squared. Does that ring a bell? No?
Oh, no.
Make a little more sense now?
Yeah.
Okay, so what's my a value over here? X. So what is a squared then? X squared. And what's my b value? B value is just the 4. You got it? Okay. So what's 4 squared?
How do we get there?
How do we get here?
Yeah.
My a is x,
Oh, yeah.
so x squared. My b is 4, 4 squared.
So it would be a squared minus b squared, but since it has a I, b squared plus b squared.
Nice. So how can I simplify that one? Well, what's 4 squared?
8, 16.
There we go. Okay, so what do I do with this step?
Now you can distribute.
Now I can distribute, because I'm not going to be having i's in there. If I distribute, what do I get?
X cubed minus x squared plus 16x minus 16.
Yeah. So I got the polynomial from those given zeros. It's a lot of work. I will say that. I think there's one more example. This one's kind of a lot, but it's not too bad. Okay. We're given a 4th degree polynomial. How many zeros in the end will we have? So how many factors in the end will we have? 4. So if 6i is a 0, what's the other 0? Negative 6i. And the factor theorem is just given. Okay, how can I write those 6i and negative 6i as factors? Yep, x minus 6i, x plus 6i. Okay, so what degree, if I distributed those out, what degree would I have? X squared. So what type of polynomial will I need to have to multiply to those to get this? X squared, which is a quadratic. So that's q of x. And that's what we're trying to find. Because we have these, so we need to find this one. So using a squared plus b squared, what does this turn into?
X squared plus
What's 6 squared? 36. Okay. So how can I solve for qx at this stage?
isolate.
How do I do that?
Move x squared plus 36 over.
How do I move it over? Not subtraction, division. Because qx is being multiplied by that one. Does that look like something you guys have done before? How do we solve that one?
Synthetic division.
Why long division? Yeah, the bottom's not linear, so we got to do it the long way. What goes on the outside? What goes on the inside? Can I stop there? Yeah, I have to put plus 0 because I could end up with something in that column. Okay, what's my first step? Yep, if I divide x to the 4th by x squared, what do I get? Okay, what do I do here? Okay, what do I multiply? Yep, so if I do x squared by x squared, what do I get?
X to the 4th power.
Okay, what about x squared times 36? Okay, what do I do here? Do I add?
Subtract.
Subtract. So what happens to the first terms? What do I do with this? What do I do with this one?
Cancels.
What do I put here?
Plus 36 there. Wait, no. You put I don't know.
Well, it's after our leading term.
Don't you divide again and then multiply?
Yeah, but we have to put a placeholder there and then drop everything down. Because since this is after our leading term, have to have a placeholder. Okay, what do I do now?
Divide x squared by x minimum by x cubed by x squared.
What do I get there?
X.
Okay, so what's x times x squared? And then x times 36?
36x.
What's going to happen here? So what are we left with?
0x squared plus 0x plus 0. What?
Well, it's just going to be 0. These are going to cancel. These are going to cancel.
That's just an imaginary.
0x squared?
So it's just 0.
Yeah, that's 0. It's
So
just a
Q of X
placeholder.
just equals 0.
Q of x
No.
equals
X.
this.
Oh, yeah, oh, shoot, I didn't see
X
that.
squared plus x plus.
There's no remainder.
Yeah.
Yeah. So can I factor this any further?
Yeah, you can actually.
This is Ohio.
How can I factor that one further?
Use square root.
No.
No.
What do
Wait,
they have in
wait,
common?
Oh, there might be magic numbers, huh?
No.
That's 0.
Stop yapping, boy. Don't say anything. That's
Yeah, we can take out an x if they both have it, because this is saying it's x times x. And if there's just an x, we can take that to be x times x plus 1. How do we feel about going from this to this? Good? Okay, so what's q of x then? Yeah, x times x plus 1. Okay, so what are all of my factors for p of x, that big polynomial?
0.
Not the zeros, the factors.
Bruh. X.
X times x plus 1.
That's what I was going to say. And x squared plus x. Oh.
No, oh, x
Yep.
plus 36. Oh, shoot. Oh.
Oh, that's what I was going to say.
Well, that's the same thing pretty much, x plus 36.
Yeah, but I don't want this form. Okay, then what are the zeros from there? -1 is one of them.
Negative 1.
6i and negative 6i.
Okay, what about this one?
Oh.
That's negative 1.
No.
What?
This one's -1. What's this one?
Oh.
Divided by.
Yeah, it's just going to be 0.
What? What is this? I'm going home.
How is that 0?
Okay. Because this is all equal to 0, so we can set each one equal to 0.
Oh, yeah, that makes so much
Oh, yeah.
So then automatically 0.
That makes sense. That was a smart one.
Okay, how do we feel about that? I know that was a lot, and it was kind of fast.
That's a lot, but I think with a little more practice, we can all handle it as a class.
I love your confidence. Okay, that's all I got. So you guys have the rest of the class to work and ask questions.